Lecture 4, Chapter 1, Measurements. So dear students, now we're going to look at mass measuring instruments. Balances were also in use by Greeks and Romans. Beam balance, such as shown in the figure, are still in use at many places. In a beam balance, the unknown mass is placed in one pan and known mass is placed on the other pan. So by comparing these two masses, the known mass, the unknown mass, we can find the unknown mass. So mass measuring instruments, there are physical balance, there is lever balance, and there is electronic balance. So first of all, we're going to discuss physical balance. A physical balance is used in laboratory to measure the mass of various objects by comparison. So the rule will be the same as the previous, the normal balance used by Greeks. So you place unknown mass on one pan and known mass on one pan and use knobs available on the physical balance to adjust and find out the mass of the object. You can find a detailed example how to find mass through physical balance in your book. Go through that. Then you have lever balance. A lever balance, such as shown in figure, consists of system of levers. When lever is lifted, placing the object in one pan and the standard mass on the other pan, the pointer of the lever system moves. The pointer is brought to zero by weighing the standard masses. So, just like the physical balance, you have to place unknown mass on one pan and the known mass on the other. And you have to adjust either the standard masses or the unknown mass in order to take the pointer to zero. Once you get your pointer to zero, you can find out the unknown mass. Electronic balance. Electronic balances, such as shown in the figure, comes in various ranges: milligram range, gram range, kilogram range. Before measuring the mass of body, it is switched on and its reading is set to zero. Next, place the object to weight, and the reading on the balance gives you the mass of the body placed over it. So what does range mean? So if you have very small object, you can switch your range to milligrams, and you will be able to find out the mass very precisely for very small object. Then there is normal range, and there is a range for kilograms. Of objects are heavier, you will use kilogram as your range. Stopwatches. Now we're going to discuss how to measure time. So there are two types of stopwatches: the mechanical stopwatch and the digital stopwatch. Stopwatch is used to measure the time interval of an event. There are two types of stopwatches, mechanical and digital, as shown in the figure. You can see a mechanical watch on the left hand side and a digital watch on the right hand side. A mechanical stopwatch can measure a time interval up to minimum 0.1 seconds. Digital stopwatches commonly used in laboratories can measure a time interval as small as 1/100 second or 0.01 of a second. So, digital stopwatches are more precise than the mechanical stopwatches. The next instrument we're gonna look at is measuring cylinder. So measuring cylinder is used to measure volume. So volume can be of liquids or powders or solid objects as well. So a measuring cylinder is a glass or transparent plastic cylinder. It has scale along its length that indicates the volume in millimeter. They are used to measure the volume of liquid or powder substances. It is also used to find the volume of an irregular shaped solid insoluble in a liquid by displacement method. So if you look at the picture, so there is a correct way and there is an incorrect way to look at the reading and get correct or incorrect reading. So you have to be perpendicular to the scale of the measuring cylinder in order to get the correct reading. That's on the person on the right hand side. So if you look from above or below, the reading, or you can say the meniscus, then you will get wrong reading. So meniscus is a layer at the top of the liquid where liquid seems to be a bit curved. So that's the top layer of the liquid, is also called meniscus. So you have to be aligned, you have to align your eye to the meniscus in order to get a correct reading. Otherwise, there might be a human error there. Displacement method. So we discussed that the object of insoluble solids can be found out by displacement method. So what is displacement method? So let's say we want to find volume of a stone. So we take stone, and the first step we want to do is take measuring cylinder, fill it half, and note the volume V1. Then add that stone into the measuring cylinder and note down the volume 2. Then we can find the volume of irregular stone by subtracting the volume 2 from volume 1. So this will give us the volume of irregular shaped stone. Rules to find significant figures or significant digits in a measurement. So you will also study this topic in mathematics as well. So first rule is digits other than 0 are always significant. So let's take an example, 27. It has 2 significant figures or digits. If you take 275, it has 3 significant figures. So all the non-zero digits are significant. Then rule number 2. Zeros between significant digits are also significant. So example is 2705. So digits between the 7 and 5, that's 0, is also significant. There are 4 significant figures in this digit. And then the third rule is final zeros after the decimals are significant. 27, so example is 275.00. So we know that non-zero digits 275, they are significant. So 3, and by the third rule we can see that the zeros after the decimals are also significant. So in total there will be 5 significant digits. Last rule, the fourth rule is zeros used for spacing the decimal points are not significant. So here zeros are placeholders only. So example is 0.03. So the first 2 zeros are just for the placement of decimals. They don't have any significance. So there is only one significant figure, that is 3. So if you take another example, 0.027 has 2 significant digits. So 2 and 7 are significant. The 0 for the placement of decimal are not significant. So if we look at the example on the left, the number is 0.002070. So according to the fourth rule, the first 3 zeros are not significant. So that's the fourth rule applied there. Then you have a non-zero digit, that's 2, and then you have 7. And the digit between them is 0, so that's the first rule and second rule applied. So for 207 are significant. So up till now we have 3 significant figure. So if you look at the last digit, so that the third rule says that 0 at the end in the decimal they are significant. So last 0 is also significant.